Hi, my name is John. We're going to be going over Charles P. McKeague, Trigonometry. The book's located right over here. Fourth edition. It could be the third or the fifth. They're very similar in nature. And we're going to be going over the last chapter of Charles P. McKeague. Section 1, first, is called complex number. The chapter itself is called complex numbers and polar coordinates. We're going to be doing a little bit about polar coordinates and what they are, but mostly we're going to be working on complex numbers. So before we start, let's go back to your childhood a little bit. Your childhood says at the end of your 5th grade, you had a problem that was imposed upon you like this. Of course, 5 minus 3 is equal to 2. But what is 3 minus 5? That's equal to negative 2, of course. But at the end of your 1st grade, you go, what? You can't have negative numbers? Well, it's actually true now. You can have negative two numbers, or negative numbers. And you go, well, wait a second here. If I had $3 right here, and I borrowed $5, I should have negative $2. Or, I'm sorry, how does that work actually? I have $3, and then I gave $5 away, I should have like negative $2. You can't physically have negative $2. It's impossible. I mean, you can owe someone $2, but you can't physically have negative $2. But you can owe someone $2, so we put a placeholder with a negative in front. So let's look at this one right over here. What's the square root of 9? What times itself equals 9? That's 3 times 3. Well, let's look at the square root of negative 9 now. What times itself, by definition, equal to negative 9? It's impossible. This is impossible. You're going to have to deal with the imaginary number now. You say, what? Imaginary numbers? So if you have a real number, then you must have an imaginary number. Imagine that. There are real numbers and there are also imaginary numbers now. Okay, and we'll talk about that. It's not that bad. Don't shiver. It's not that hard. We'll start off really easy, nice and easy for you guys. Okay. So how do we solve problems such as this? We're going to call I, by definition, square root of negative 1, because we don't know what times itself equals negative 1. We're going to call that I right there. Okay, imaginary number I. So let's start with this problem again. Square root of negative 9, that's the same thing as square root of negative 1 times 9. We break that out. That becomes square root of negative 1 times the square root of 9. And square root of negative 1, by definition, is I. And square root of 9 is 3 times 3, or you have 3 i's. Okay? And I'm going to show you how to do that on your calculator a little bit. I don't know if you can see that or not. Turn it on first. And make sure on your mode right here, you're in the A plus BI mode. Right there, the A plus BI mode. And if you're in the real mode, let's say you can't really work this problem out. If I take the square root of negative 9, it says non-imaginary answer. I'm sorry, non-real answer. Okay? But if I go into my mode or my mood, you got in the right mode to study, same thing, right? So if I take that again, use the entry button, second and entry, I come up with 3 i's. There it is right there, 3i. Okay? So you know how to use it on your calculator now. So let's look at some of the problems. Example number 1. What's the square root of negative 9? That's the same thing as square root of negative 1 times the square root of 9, which is equal to 3i. We just did that. Pretty simple. A shortcut for square root of a negative number, whatever it is, just go I times the square root of that number. So you're taking the negative out of the fraction, out of the radical, to make it an I. And that's the shortcut. We're going to use this shortcut quite a bit. So what's example, the second example is square root of negative 12. That thing is same as taking the I out. Take your i's out. Square root of 12. Square root of 12 is simplifying that radical. It's going to be 4 times 3. It's going to be 2i radical 3. Okay, and the second part, the third part is square root of negative 17. Take your I out, you get I root 17. That's your final answer. Okay. Let's go on a little bit more. So, a complex number now is defined by the form a plus bi. It's complicated, it's complex because this is the real portion, this is your imaginary portion. Okay, let's do an example. 3 plus 2i right there, that's your real, so your real is equal to 3, your imaginary portion is equal to 2, not the I portion. Okay, is negative 7i a complex number? Of course it is. You go 0 minus 7i, your real is equal to 0, your imaginary is equal to negative 7. How about 4? Is 4 a complex number? Of course it is. You go 4 plus 0i. In other words, you have your real part, which is 4. You have your imaginary part, which is 0. Okay, so 4 plus 0i is the same thing as 4. We got rid of that. Okay, so let's start on another problem set. A plus bi is equal to c plus di. This real portion has to equal this real portion, so a must equal b. This imaginary part has to equal that imaginary part, and b must equal d. So let's do an example on that. We use example 3. So you have find x and y if negative 3x minus 9 plus 4i is equal to 6 plus 3y minus 2i. So here's the real portion right here. There's your imaginary. There's your real portion. That's your imaginary portion. We're going to set the real equal to the real. So negative 3x minus 9 has to equal 6. Adding 9, that's 15. Divided by negative 3, x is equal to negative 15 over 3. It's going to be negative 5. Okay. Set the imaginary equal to the imaginary. The 4 has to equal, there it is right there. We're trying to find x equals what and y equals what. Okay, got it so far? You're going to set the imaginary portion equal to the imaginary portion, 3y minus 2. I add 2, that's 6 divided by 3. Y is equal to 6 divided by 3 is going to be 2. Okay, that's not too bad. So, how do we add complex numbers and subtract complex numbers? Let's get started with some problems. Example 4. It says that C1 is equal to 3 minus 5i, C2 is equal to negative 6 minus 2i, and I want you to find C1 plus C2 and C1 minus C2. So we add them up. 3 minus 5i plus negative 6 minus 2i. We add the real portion, 3 plus negative 6, C1 plus C2. It's equal to 3 minus 6 is negative 3, minus 5i, minus 2i is going to be minus 7i. So you add the real portions and then you add the imaginary portions. Let's do C1 minus C2. 3 minus 5i minus negative 6 minus 2i equals what? That's going to be C1 minus C2. We add the real portion. 3 minus negative 6 is, we're adding that, so it's going to be 3 plus 6, which is equal to 9. Negative 5i plus 2i. Negative 5i plus 2i is going to be minus 3i. So C1 minus C2 is 9 minus 3i. The power of i's now. This is kind of really important, and we'll do some examples of that. Okay. We defined I as the square root of negative 1, which is just I. That's fair. So what is I squared? I squared is going to be the square root of negative 1 quantity squared. So whatever that I is, we're going to square it. What's negative square root of, square root of negative 1 times the square root of negative 1. The square and the square root cancel, you end up with negative 1. In other words, if I take this calculator, there's an I button right over here. You can see a little bit better. If I take I right there and I square it, I should end up with a real number. In other words, just like a placeholder for negative $2, you can't physically have negative $2, just like a placeholder. If you square it, becomes a real number, in other words. Okay? Just a real portion, negative I. I'm sorry, negative 1. So what's I cubed? I cubed is equal to I times I squared. That's fair. I times I squared is I cubed, of course. It's going to be I squared is negative 1 times I. It becomes negative I. Okay? I to the 4th is equal to, I'm going to do it this way, I squared times I squared. I squared is negative 1 times negative 1 is equal to 1. So these are really, really important. Okay, guys? I'm going to do it for you over here. I'm going to go I, second. There's your I button right there. And then I'm going to raise it to the 4th power. That's called a caret key. You end up with positive 1. Okay? So, what is I to the 5th? Is equal to I times I to the 4th. I to the 4th was 1. So I to the 5th is equal to 1 times I, which is I. You notice we're repeating the process every single time. If you go I to the 6th, it's equal to I squared times I to the 4th. It's going to be 1 times I squared. You end up with negative 1 again. And up to I to the 6th, it's pretty simple. Make sure you got the reflection right. There's your imaginary number, and you raise it to the 6th power, you end up with negative 1. Okay, perfect. So something for you to memorize is I equals I squared equals negative 1, I cubed is equal to negative I, and then I to the 4th is equal to 1. If you're allowed to use your calculator, you don't have to memorize it because you can grab all of these. I, exponent 3, it's going to be negative I. There it is right there. Okay, I don't know if you can kind of see that or not, but it should be negative I. So, let's do an example 5. I don't like the way the book does it. It's kind of a little bit hard to understand. So I'm going to write it this way. I to the 20th is equal to what? Well, the way I'm going to do it, I'm going to go 20 goes into 4. It repeats every 4 times. So it goes into it 5 times. Minus 20, 0, the remainder is 0. If the remainder is 0, this is remainder 0, remainder 1, remainder 2, remainder 3. So in that case, it's going to be 1. Okay, let's do I to the 437. Well, 437, it repeats every 4 times. 4 goes into 1, subtract 4, 0, add the 3, 0 times, subtract 0, you get 37. 4 goes into 37 9 times.